Hello, welcome. I'm really pleased to see so many of you here. I'm Alan Willison, Chairman of the Hertford Astronomy Group, and it's my pleasure to welcome you to this meeting. I can see lots of new faces, which I'm really pleased about, and of course the familiar faces, which I'm equally pleased to see as well. For those of you who are new to us, I'll explain one or two house rules to begin with. The first one being the safety. Should the fire alarm go off, please exit via the emergency exits each side. Congregate on the car park. We will check that everybody is safe and sound. For those of you new to us here, if you haven't found them or need them, the toilets are just outside that door on the other side. And for the convenience and pleasure of everybody else here, could I ask, if you've got a mobile phone, could you please set it to silent or switch it off or do whatever you have to do so that it doesn't go off in the meeting. And for those of you on Zoom, it's lovely to see you here as well. I'm not sure how many there are of you because I haven't got my connection going, but it's lovely to see you as well. The only rules really for yourselves on Zoom is please keep your hand away from the space bar, otherwise you might start a conversation you wished other people didn't hear. We've got our sort of regular format of the evening, and that is in a few moments' time, John Fraser's going to give us a talk about the night sky. Following that, Jerry, would you introduce our speaker for the evening? Right, we're very pleased. I won't say any more about it now, but we're very pleased to see Roger here again. And then after the talks, I will give a few closing remarks about upcoming events for the club. After each talk, there will be the opportunity to ask questions. So we ask for the people in the university, if you've got a question, just wait for us to come round with a microphone so that everybody in the auditorium can hear you and the people on Zoom can hear you as well. For those of you who are on Zoom, if you have a question for any of our speakers tonight, if you could use the chat facility, type your question in and we will make sure it gets read out. So I think that's about everything I need to do as an introduction. So I'm going to pass you over now to John.
Okay, hello, sorry. Welcome, Night Sky and News for about the next month. So I'd like to start off with a short highlight to a constellation, and this month I've picked Andromeda, just over here. Now, in legend, Andromeda was the daughter of Cassiopeia here and her father Cepheus. Cepheus and Cassiopeia were the king and queen of one of the many Greek states.
Ethiopia.
I thought it was pronounced Ethiopia, but I thought if I said that, I've got it wrong. Okay, so they were rulers of Ethiopia. Cassiopeia rather stupidly said that Andromeda was the most beautiful woman in the world, which upset Poseidon. Poseidon, as is the way of the gods, sent a monster to destroy the city. Andromeda's father, Cepheus, he did the sensible thing that any father would do. He tied his daughter to a rock as a human sacrifice to appease the gods. Fortunately for Andromeda here, Perseus was flying by, and you can't see in this artwork because, well, I can't. He's got the head of Medusa, which he used to petrify the monster, and took Andromeda away as his queen, and she lived happily ever after, but I imagine dinner with the in-laws was a little bit difficult after that. Okay, so if you're looking for Cassiopeia, if you're looking for Andromeda, the big W of Cassiopeia, which we went through a few months ago, is a very good sign. This W, which is also known from now on as the Bluetooth sign, points very much down towards Andromeda. 3 stars here, which are relatively bright. This one, Almach, and 2 others are about magnitude 2, so they're fairly bright. So you can see them if you look for them and you get used to it. A few nice things in the sky. We've got, aptly for tonight, a Messier object, M31. This is the Andromeda galaxy, the great galaxy in Andromeda. This is about 1.5 times the size of our own Milky Way, and it's heading this way. Last time I read, there's a 50% chance that the Andromeda Galaxy is going to collide and merge with the Milky Way and make Milkdromeda. Won't happen. I didn't make up the name. 4.5 billion years, 5 billion years, which is enough time to think of a better name than that one. We've also, Almach, this star here, is a very nice, pretty double star, 2 different colours, resolvable in the OK telescope, well worth seeing. All right, so what's happening? We've got the moon going through its phases as it's wont to do. Currently, we're sitting at about third quarter, and we're going to hit full moon just before the next meeting. We got the moon's going to pass through the Pleiades in Taurus on the 21st of September, and it's going to do it again about a month later. I think it's the 10th of October, which is just after the next meeting. I know Richard last time put together quite a nice little series of the Pleiades falling behind the moon. So Mercury is, right down the bottom here, Mercury's rising in the east at sunrise about half an hour before the sun. Always say this, do not try to look at Mercury through a scope or binoculars once the sun is in the sky. It is very bright at the moment though, so it's at 0.82, so you will be able to see it. The only problem is Mercury is slowly moving down towards the sun, or to the left of the sun as shown there, and it's going to get more and more difficult to see as the month goes on. Venus, on the other hand, is at minus 3.95. This is astonishingly bright morning star. It hits perihelion on the 2nd of September. It's going to be occulted by the moon. The moon is going to pass in front of Venus at about 1 o'clock in the afternoon on the 19th of September. I don't know when Venus is that bright, whether it would be possible to actually see that if you knew exactly where to look through a scope. It might be worth a try. Jupiter's moved out of Taurus. It seems to spend most of the year in Taurus, but in the summer it's crossed into Gemini. Very bright as well. It's rising late at night, about 1 o'clock in the morning, and it's gradually, and it will set later. Saturn is actually getting very good to see at the moment. So it's in the sky, low in the east at sunset, and it's going to be up all night. It will set towards the south at sunrise. But its magnitude 0.63 is quite bright. It's about to hit opposition, so it's about as bright as it's going to be for a while. But it's starting to tilt again. So the rings, which were just aligned a little while ago, are gradually going to open out over the next few years. Neptune's never bright. 78.81, you won't see it anywhere with the naked eye, unless you've got incredible vision. But it's also hitting opposition, so it's about as good as it can get. And Saturn is nicely lining up so that you can find Neptune. Assuming you haven't got to find this scope, I'll do it for you anyway. Okay. Uranus still hanging around the Pleiades, so probably will get quite a close encounter with the moon. Oh, sets in the so again low in the east. That might be wrong. That opposition. I've got a feeling it is an opposition. I think I may have cut and pasted that from the other slide. So citation needed on that one. My apologies. Okay. So right, this is quick through the last few months. I've actually not really been following the news over the last few months that closely, and these are just things that caught my eye. Many other things people may come to. So the Vera C. Rubin Observatory got first light. I've mentioned this before. This is an incredible telescope. This telescope has 3.5 degrees of view. It's going to scan the whole of the southern sky in about a week, might be 2 weeks. Every night, 20 terabytes of data will come through. The mirror is 8.4 meters. It's one of the biggest unsegmented mirrors of a telescope. The idea of this telescope is it's going to survey the sky continually for 10 years. There'll be 60 petabytes of data coming out. And the idea is to map where dark matter is in the universe to give us a better understanding. Of course, Vera Rubin, her work with the rotation of galaxies, which arguably should have got her a Nobel Prize, didn't, possibly because she was the wrong gender. she gets this cool observatory named after her because her work led us to dark matter. But the thing about this telescope, this thing is going to discover more comets, more asteroids, more supernovas, and more things that we haven't even got a name for yet than any other telescope around at the moment. It is incredible. This is actually the Lagoon Nebula. Have I got that right? Yeah, sorry, the Trifid Nebula. And this is the Lagoon Nebula. This is 678 images made this. So it's not fully operational. It's just first light. It's just starting. But this is, you're going to see this turn up on a lot of bits of news. Okay, so ESA, I said start the construction. They've certainly signed the contracts. LISA is the Laser Interferometer Satellite Array, space array. It's 3 spaceships flying in formation with lasers linking them up over 2.5 million kilometres in a triangle, 2.5 million kilometres on each leg. It's a gravity wave detector. Now, mergers of supermassive black holes cause very, very long wavelengths of gravitational waves. LIGO can't detect them, they're too short. So this can detect them. They did a test mission in 2015, which was very much smaller. It was only a few centimetres long, but it was very, very successful. They're aiming to have this launched by 2035. We have a new astronomer royal, Professor Doherty, Michelle Doherty. She is space physics at Imperial College. She was the lead researcher on NASA's Cassini mission and ESA's Jehovah Nicey Moons Explorer, JUICE. She is the 16th astronomer royal. The first one started in 1675. And I had to look up. I didn't know what an astronomer royal did until I looked into this. They started to try and work out the longitude problem, which was solved quite a long time ago. Now they advise the monarch on matters about space. I'm sure what matters Charles needs to be advised on, but we'll carry on. And we've got another interstellar visitor, the 3rd interstellar visitor that's been detected. This one's about twice as big as the last 2, and it's travelling at 60 kilometres a second, so it's going a lot faster. Now, gets closest to the Earth about there. It was really well timed by me, I think. It's about 1.8 astronomical units, so it doesn't get very close to the Earth, but it does get very close to Jupiter. And there has been a suggestion about using the Juno probe that's going around Jupiter at the moment to intercept it. There are questions about Juno's got enough fuel. Frankly, I think it's just an idea someone come up with. I don't think it'll happen, but it would be really, really cool if they did. This, judging from the direction the comet's coming at, they reckon this is about 7 billion years old, which is significantly older than our solar system, and is by far the oldest comet we have ever seen. Okay, right, China. China, you did a tethered test of their manned, or their crewed. I hate saying crewed because it always sounds like, yeah. I hate saying manned but their crewed lunar lander. They did a tethered test, 30 seconds, worked really well. China's aiming to get to the moon by about 2030. It doesn't look like the lunar lander, but you can certainly see they come from the same sort of idea. This one, I think, could do 26 metric tons to the lunar surface. The Apollo, I think, did 10.3 metric tons. He looks at Jerry to see if he... So, all right. Starship 10 launch, this hit the news. They'd had 3 Starships blow up. They'd had a heavy booster then blow up on the test pad. This one went pretty well, much more successfully. Starship launched 8 dummy Starlink satellites coming out. This is quite important to SpaceX. I don't know if this is true, but apparently Starlink is going to produce more money for SpaceX than the entire NASA budget. I couldn't decide if that's a bad thing, but on the whole thing, I think that is a bad thing. But, okay, they didn't catch the booster this time because it came in at a steeper angle of attack. That was deliberate. They wanted to test the strains on the Starship. And they did have a couple of problems. There was an explosion in the bay, but it did pretty well. They hovered it above the ocean and then dropped it, apparently, to make sure no one could pick it up. Okay, this is really important though, and it only occurred to me when I wrote this down. Starship is the foundation for the lunar lander on Artemis 3. Artemis 3 is scheduled in about 18 months' time. And you think, well, we've got China is getting ready, they've got their lander tested, and they're talking about 2030. This supposedly we should be ready for the middle to late next year. It's only 18 months, roughly, they've got. Not next year, year after. We also had a lunar eclipse. A couple of images people from the group did. Chris, I apologise, I don't actually know your surname, but he's got a lovely red moon. I think he took this one in Greece. And Sean, I can't actually remember where he did this one, but you get a nice red colour. Sorry? Sandown on the Isle of Wight, okay. I know other people have problems seeing it. We missed it altogether. Okay, so what's happening next month? I mentioned Juno. They might use Juno to intercept 3i Atlas. Juno, if they don't, it's had multiple extensions. It's been going around Jupiter for years. They're going to crash it into Jupiter, similar to the fate that Cassini experienced. This is to stop them contaminating the moons of Jupiter where there might be life. It'd be really nice if they did intercept Atlas. We got solar eclipse. We had a 30% solar eclipse at the start of the year. This one goes to 80%, but you've got to go to Murdoch Station in Antarctica to get that. But if you happen to be in New Zealand, I think it hits 70, someone might be, it hits 70% in Christchurch. So we hit the equinox. You wouldn't believe it, winter is coming. Felt like it today. There's going to be a New Glenn launch, the second New Glenn. New Glenn is Blue Origin's reusable launcher. It's sort of competitor to the Falcon Heavy. Originally their first launch was supposed to launch 2 probes to Mars. It's going to do it this time. We got a meteor shower. I just like putting a meteor shower. This one's not very good. They're never any good, to be quite honest. But 10 meteors an hour. But in 1933 and 1946, it did 2 spectacular displays that were 2 of the best meteor showers of the century. Right, this last one, the Dream Chaser cargo, they might launch it. I've included this one because I think that is just an awesome looking spaceship. It really is. This was in the competition with the Dragon capsule and the Starliner for NASA to be the manned spacecraft. It didn't make the final cut, so they cut it back to a cargo one. It's launched on a Vulcan Heavy, and it flies back to Earth, lands on a runway. It doesn't really have wings. It's actually a lifting body. The shape of the spacecraft allows it, generates all the lift it needs. I just think they should build this as a manned version because nothing looks as good as this one. That's what spaceships should look like. Okay. So, I haven't got very many from the group today. I've been away and I didn't have a lot of time to pull some photos out, so just four really good ones. The Tulip Nebula, this is, I've got his name, I thought I hadn't put his name on there. This is the Tulip Nebula, it's about 6,000 light years away. Nice emission nebula. Martin does some fantastic nebulas. And this is seated in Cygnus. Okay, the Swan. Right, this one is from Steve here on my left, the Dark Shark Nebula. Now, Steve actually says this is one of the hardest images he's ever had to do. The darkness, this is a dark nebula, so it's not letting the light through, and you have to pick it out against the darkness of space. So this is about 650 light years away from us, and you can tell I've memorised this. Steve took this in Spain, about 8 hours of photography. absolutely wonderful. Cited in Cepheus, which hopefully you'll remember, was the husband of Cassiopeia and the father of Andromeda. And the big W points at Andromeda, which would be just over there. Another one from Martin. Another Messier object. So this is Messier 8. About 6,000 light years, 46,000 light years away from Earth. Another emission nebula. This is in Sagittarius, and this and the Great Nebula in Orion are the only two star-forming nebulas that are visible to the naked eye from the northern hemisphere. Okay, and the unexcitingly named RW134. This is a Wolf-Rayet star. Wolf-Rayet stars are rarish stars. They're rare stars. They're incredibly hot. They're supermassive, or they're massive stars that are reaching the end of their lives. This star is about 5 times as big as the Sun, but 400,000 times as bright. It has a surface temperature of 63,000. And you can put Kelvin there, or you can put centigrade in there, because when you're at 63,000, there is absolutely no difference between them. It's lighting up the oxygen that's been blown out by the star. Incredible amount of power and energy they put out. They do not live very long in this state, and it will go bang at some point very soon on stellar timescales. Okay. And this is another one, like the first one was in Cygnus, this also is in Cygnus, not far from it. And that's it. Any questions? Thank you.
So just interested in the comet that's appearing, is there any chance of actually seeing it either by telescope or eye? Or?
Thank you, I missed that. That is on my notes. There's no chance of seeing it by the eye. Its brightest is going to appear as 11.5 magnitude, and with good eyes in the dark side, you're probably not going to get better than 7. It's the end of October. You should be able to see it in a telescope towards the end of October. When it's at its brightest, so yeah, but sadly not with the naked eye. It's produced a lot of carbon dioxide, I believe. It's got quite a big cloud, came out very early, but again, I don't know how visible that will be, even in a telescope. If I go back, that was, I think, James, that picture there. Oh. If you imagine the comet there, no, that picture I think was James Webb, but obviously a lot further away.
Okay, well, thank you very much indeed, John, for a terrific presentation. And of course, thank you very much, everybody who contributed pictures towards it. I think it's amazing what these people get up to from their gardens in light-polluted Hertfordshire. So, I'm now going to pass you over to Jerry, who's going to introduce tonight's speaker.
Thank you, Alan. Well, our speaker tonight doesn't really need much of an introduction for long-term members of the society. He's actually the reason we're here. He had a career in banking, and
long time ago now.
Yes, and he said he survived to do a BSc in astronomy, and he got to the point of teaching astronomy. And it was a course that he held at the Seeley School in Hertford that some people who became the founder members of the Hertford Astronomy Group, that's how he got the name, attended that and then decided they'd like to do more with astronomy. And so they didn't call themselves a society because it was only a small group, as it was at the time. And it has grown and grown and grown. And we always invite Roger to give the first presentation of our program for each year, and he is our president of the society, which he said he's extremely proud of. We are very proud to have him here. So as for his subject tonight, can you imagine if you are a professional astronomer and you are studying the heavens and you have a particular interest and you have a problem with that interest, and as a result of that you become famous for something that you did which is not what you wanted to study.
I can go home now, he's pinched it.
No. Please welcome Roger to talk about Charles Messier. Thank you.
Thank you. Okay. I think that's us, isn't it? Yeah, that's it. Charles Messier. That's my attempt to pronounce it in French. Not really all that good, but you can't win them all. If it was German, I could do it slightly better, but not much. Okay. So I said there, Messier discovered 13 comets. Every source you look at gives a different number. And Messier himself claimed to have discovered 20 comets. He did wangle that a bit, but we'll come on to that later. You notice most of them sort of got his name after them. One or two didn't. Comet Lexell was actually named after a Finnish mathematician who derived the orbit, but it was actually Messier who led the actual discovery of it. And this is what Jerry was just saying. It's perfectly correct. Messier wanted to be remembered for finding comets, but Sod's law intervened. You know, the famous phrase that somebody's turning in their grave if things... Yeah, he's remembered for his list of objects that were not comets. It's not fair, is it? Mind you, I do find this with astronomy. Firstly, Messier is a bit disappointing. Most astronomers are mad. So they're really good for quotes. Yeah, because they have lots of lovely feuds which are interesting, you know. But Messier seems to have been quite a nice bloke, which makes telling the story of his life quite difficult because there's not much to hang it on. Because in this country, I mean, we all know about M numbers. How many people even know the name Messier? I expect you lot do. But if you ask 500 people in the street who was Charles Messier, I bet you wouldn't get more than about 5 answers if you were lucky at that. In English, his name is an adjective, isn't it? Messier. And he's known by his initial, M. Funnily enough, this is the first general catalogue. Before then, people had done catalogues of stars, but nobody had ever done a catalogue just of objects, whether they weren't stars, but could be clusters, nebulae, all sorts of things like that. That's the only picture I could find. Well, there's one other picture of him, of Messier, the man of the M numbers. And you notice that he's sporting... Let's play with this. Let's just show I can use it. There we are, look. That's the Légion d'honneur, my bad French again, the Legion of Honour. Now, this is interesting because the portrait's been mucked around with. It shows Messier at about the age of 40 in 1771. He didn't get the Légion d'honneur till 1806. It wasn't even started till 1802. So there's been a bit of wangling going on. Not that that's all that rare, particularly if you think about the time. You know, that picture was painted in 1771, which is it's less than 20 years before the French Revolution. And a lot of people who had pictures showing decorations awarded by the king would have had the decoration painted out or separate, something new put in. So it's possible that one explanation of that is that he had a previous decoration and that was painted out. I don't know. It's a possible answer. He was born in Badonviller, which is in eastern France. It was in what was then the independent Principality of Salm. It had French troops all over it. So how independent it really was is quite difficult to say. But I mean, for instance, Lorraine didn't become officially part of France for some years yet. So, and after all, those of you who know your history, Maria Theresia's husband was Charles of Lorraine, but he was a German. I hope you're taking notes, because there will be a quiz at the end, and you're not allowed to leave till you've got past. Okay. This is one of these things you find about people in the 18th century. Messier, Charles Messier, was the 10th of a dozen children. They had big families. And as it says there, 6 of them died in infancy. That's not an unusual death rate. It's quite appalling when we think of it now. But it does explain why sometimes, if you read books written around about that time, there does seem to be a slightly casual, almost callous attitude to infant mortality. It was so common. Anyway, his father died in 1741 when he was only 11, and his elder brother, I think it's a wonderful name for a man, Hyacinth, who was then 24. He took over the father's role in the government of Salm and also in the education of Charles. And it must be said that he seems to have done a pretty good job in educating Charles, because Charles had a good writing style, he was fluent and so on. His writing becomes important for other reasons later on. He also was capable of mathematics and so on. And he was taught to be diligent, to do things properly. And I think that's one of the things we've all learned about astronomy, is if you want to do it seriously, like a career, I mean, if you're like me, you can just sort of look at the sky and say, oh, that's nice. And that's good enough. But if you're going to do astronomy properly, you've got to do it properly. If I can just take a quick digression. Some years ago, I was reading the memoirs of an archaeologist, and one of his favourite things was a tablet from Sumeria, dated to before 3000 BCE. And it's an astronomer's report. Apart from the fact that it's written in cuneiform and it's written on a clay tablet, it could be a modern observation report. It's got everything. It's got who was there, what they were looking for, what time they were looking for it, what they saw, what conclusions they drew. Yeah, could be one of Patrick Moore's reports. So 5,000 years ago, they could do astronomy properly. There are times when you listen to certain governmental organisations when you wonder what's happened since. Perhaps I shouldn't go into that. Anyway, Charlie seems to have been a fairly active child. I tried desperately to find out more about this, but I couldn't. He fell out of a window and broke his leg, which I would have said was damn careless. I mean, you shouldn't go hanging out of windows, certainly not high enough up to break a leg, I mean. Anyway, he did. And again, this is another thing that you find about these he's coming from a relatively well-off family. He was promptly farmed off onto a local family to get better. This was a fairly standard thing. If you read your Jane Austen, you'll find this sort of thing goes on a lot. Anyway, Hyacinth saw to it that he got a good education, and Hyacinth was basically equipping him for an administrative role, something like the role that he himself fulfilled in the Psalm government. So he taught him to work methodically and record things carefully and properly and fully. Back to our Sumerian example. I'm glad I've written that. I'd completely forgotten this bit. Was it John said he hadn't read through his slides beforehand? You can tell how much I've read through these. Anyway, Messier saw this great six-tailed comet. Actually, multi-tails are not that uncommon. But seeing them from Europe tends to be harder. For some reason, comets seem to like the southern hemisphere. Anyway, great six-tailed comet of 1744, and then in 1748 he saw an annular solar eclipse, and he saw that from his hometown, Badonviller. Perhaps an annular solar eclipse, if you're somebody who's already getting a little bit of interest in astronomy, an annular solar eclipse might have more oomph. It's much more unusual. And yeah, I mean, again, let's just make sure. Do you all know what they mean by an annular solar eclipse? Nobody said no, okay. Later on, 1751, he was employed by Delisle, who was the astronomer of the French Navy. So that would have been a position not that different from Astronomer Royal in England at that time. Not what it is now, but what it was then. And the first of Messier's observations was that's recorded, where we have the record, was of a transit of Mercury on the 6th of May 1753. Transits of Mercury, of course, are much more common than transits of Venus. Transits of Venus are most, Jerry will back me up on this, I'm sure, they're inconvenient. I mean, there wasn't a single transit of Venus in the whole of the 20th century. I wondered if I was going to live long enough, but my kids assured me that as they'd forgotten to get me insured, I would. And funnily enough, I did. But, you know, transits of Venus occur 8 years apart. Then you've got a gap of about 125 years, and then you get another 2 or 8 years apart. Crazy system. If anything was wanted to prove that the argument from design doesn't work, that's the sort of thing, as far as I'm concerned, that proves it. Anyway, transits of Mercury are much more frequent. They're much more difficult to observe. Mercury is a lot smaller and it's further away. Also, I am told, I've never bothered to check this up, that is, I haven't bothered to look at it personally, but I'm told that the black drop effect, which has caused a lot of problems with Venus observations, is relatively worse for Mercury. Now, most of these observations were done from what was then called the Hôtel de Cluny in Paris. Shows you how much smaller Paris would have been then, because this would have been right on the outskirts. Even so, I mean, Greenwich in London was effectively no use as an observatory by about 1850. It wasn't all that good back when it was founded. I mean, the reason they put the observatory there was that there was a castle there before which had fallen into ruin. But there were foundations, so they didn't have to dig new foundations. Cheese paring by governments is nothing new. That's a contemporary picture of the six-tailed comet. That looks pretty good, doesn't it? I wouldn't mind seeing that. That's apparently done from Lausanne, 8th of March 1744. You could quite see why that would get a young lad. He would have been 13, 14, something like that. You can quite see why that, if you had the least bit of interest to start off with, that would get you roused up, wouldn't it? Well, it would me. Because it wasn't all astronomy. I'm jumping around the chronological scale a bit. I always do. 26th of November 1770, Messier was by then about 40, and he married Marie-Françoise de... I can't pronounce that. It's too French. Who was only 3 years younger than him. Now, particularly in France, a 40-year-old professional man marrying a woman who was 37 would have been very unusual. You'd have expected a 40-year-old man to marry a woman of about 25, if not younger. So this suggests that they actually did something dreadful and perhaps even liked one another. Yeah, it does happen. They'd known each other for 15 years, apparently, since Messier had worked in the original premises of Delisle's Naval Observatory, which are in the Collège de France. Anyway, initially they lived in an apartment which was made available to them from the suite of rooms that was available to Delisle and his wife. And they moved out of there and set up on their own. Unfortunately, things didn't go all that well. Messier got these lodgings in the Hôtel de Cluny, so he's gone back there. And that was where the Marine Observatory operated. As he was by now the chief operator of the Marine Observatory, that was probably a good thing. And then on the 15th of March 1772, Françoise gave birth to a boy, Antoine Charles. She died on the 23rd of March. To make it worse, the little boy died 3 days later. And that seems to have been that. There's no record of any other woman in Messier's life. Or, put it this way, I couldn't find any record. Yeah. I'm not really a researcher, so and I can't read enough French to read any original text. So I can just about read a menu in French, but that's it. Anyway, just an aside on this, we've already slightly hinted at this, but in the 18th century, particularly if you lived in a town, and particularly if you came from the gentry or the lower nobility, giving birth was a risky business, particularly if, as the case with Madame Messier, she was an older first mother. Even now, they take a lot more trouble with women in their late 30s than they do, say, with women in their early 20s who are giving birth to their first child. And certainly in those days, that would have involved extra risks. Why do I say sort of gentry, lower nobility, that kind of thing? Because they had a different lifestyle, which probably wasn't so healthy. They didn't get so much exercise, and they gave birth in bed, having had a confinement, which generally meant being kept in bed and overfed. In fact, you're better to have a normal amount of food and get plenty of exercise before a child is born. But that's not how it was done. And of course, it's entirely possible that Madame Messier realised that she was taking a big risk. Not that there was necessarily much she could do about it. Remember, France is a Catholic country. So although some methods of contraception were actually known by then, they were not likely to be applied by the servant of the government of His Most Catholic Majesty. Now, Messier had arrived in Paris back in October 1751. His father and a relative, the Abbé Telozen, it's funny, I'm pronouncing the first bit in French and the te is French, but Lausanne I'm pronouncing in German. Don't know how you pronounce it in French. Telozon, I should think. Anyway, was a family friend, and they had, between them, pulled a few strings, and they got Messier a job as one of the assistants to Joseph Delisle, who was astronomer to the French Navy. Messier received lodgings in Delisle's apartment, well, they were then in the Collège de France. That's Delisle. Looks worried, doesn't he? Don't ask me why. In the end, he actually, excuse me, arranged to put together an observatory at the Palace of Cluny, and that's where Charles was his apprentice. His exact status with Delisle, first of all, is difficult to define. Was he an apprentice? Was he an assistant? Was he a secretary? Because he seems to have fulfilled all of these roles. And of course, he was 21. So if he was any good, his status was likely to change pretty rapidly, and it did. Apparently, Messier had a very small, neat handwriting. Elegant, meaning legible. And this was important because one of his first jobs was copying a large map of France. And if you think about it, reading the captions on a map is actually quite important. So it is vital that they be written in a clear hand, but there isn't much room, so they've got to be a small hand. You're no good employing me. I've got, big scrawly handwriting. Now, Delisle actually established the observatory in 1748, which is before Messier joined him. And he already had a secretary called Libour. And Libour apparently played the major role in teaching Messier how to use telescopes and in making sure that Messier, who I think already had a bent in this direction, kept proper records. If there's one thing you need if you're going to do astronomy properly, it's proper records. One of the reasons that the Babylonians made such advances in astronomy, and remember, it was essentially Babylonian records that enabled the Greeks to take their steps forward in astronomy as well, was that Babylon could draw on records, in some cases going back 2,000 years. Because although empires, kingdoms, God knows what else had changed, the basic religion of the Fertile Crescent really hadn't changed. There were still astronomer priests all the way through that. They still used the same cuneiform, and they still made the same observations. Oh, 1754, Messier became a paid clerk in the French Navy. That doesn't sound terribly significant. But remember, a paid clerk in the French Navy is actually going to be a senior official. We're not talking about somebody, sitting in a corner copying out notes or anything like that. I'm talking about somebody who's in charge. And he got all that sorted out, career nicely set out in front of him, and then a rather inconvenient thing occurred. They call it the French Revolution. Began with the storming of the Bastille. Incidentally, if you ever have a chance to read up on that, if you don't already know about it, it's not quite what they would have you believe. I think there were 17 prisoners in the Bastille, several of whom were there because they were mad. It was defended by a total of, 120 men or something like that. And it wasn't quite the sort of epic contest that it's often made out to be. But the storming of the Bastille and the subsequent revolution upset the French economy very badly, and the French economy was in a terrible state anyway. Why was it in a terrible state? Well, the French had supported quite generously the rebellion of the colonies, the British colonies in America. And while they had ensured that the rebels won the war and became independent, the cost to the French economy, which was already reeling from the cost of the 7 Years' War, was fatal. In fact, you could make a very good argument that without the American rebellion, the French Revolution might never have happened. But if there were no funds available, and something like astronomy, which was seen as upper class, exclusive, unnecessary, wasn't going to get whatever money was available. So Messier's work, by this time he was in charge of the Naval Observatory, Messier's work was severely curtailed. He did manage to observe Ceres and Pallas, which were discovered in Ceres was 1801, the 1st of January 1801, first day of the 19th century. And because they were then, but not for long, called planets. And apparently no one stood up to defend them when they were downgraded. I think you all know what I'm referring to. I actually debated whether Pluto was a planet or not with Patrick Moore. I think you can probably work out who won. I was speaking for it's not a planet, by the way. Okay, so two of Messier's great works came out of the same observations. Obvious point to make. Delisle had done a lot of work on the comet that we now call Halley's Comet, and he had predicted its path through the heavens. And he'd also predicted when it would return. He wasn't the only one, by the way. Halley had also said roughly when it would return. Halley made the mistake of assuming that telescopes wouldn't improve. So he reckoned that it would be something like 6 months after it was actually recovered, or he didn't allow for a big enough improvement, whichever way you like to put it. So Halley predicted it would return in 1759, but actually they picked it up in late 1758. Messier started searching for it in 1757, which may, considering the sort of telescopes he had available, may have been a bit on the ambitious side. He certainly wasn't the only one in Europe who was looking for it. And he had another disadvantage. Delisle had not calculated the path or the arrival time accurately. So Messier was consistently looking in slightly the wrong place. And that was also, 1757, was the year that Messier first looked at M31. It was simply later to become the 31st object in his list. Notice up to now I haven't really mentioned the list. The list doesn't matter yet. It's only starting to become important. Although that was number 31 in the list, that wasn't necessarily the 31st object he'd looked at. He was actually conducting routine sweeps on a regular basis for Halley's Comet and not finding it. But, as it says there, 12th of August, 1768, that should be 58, Roger. Yes, should be 58, sorry. Messier independently discovered Comet de la Nux. I don't know if that's the correct pronunciation, I have to do. And then he found this small nebulosity in Taurus. And he did the usual thing, a vague fuzzy blob Incidentally, did you know that is the most common technical term in astronomy? I owe that insight to Patrick Moore. Anyway, he made a note of this, and the first thing he noticed was that it didn't move. It's a permanent blob, fuzzy blob. And that would later become M1. And I think most of you know that M1 is the Crab Nebula. It's odd that it should be M1 because it is often an extremely difficult object to pick up. Well, you know, M31 is an absolute doddle by comparison. Okay, yes, you can see it should have been 1758. 21st of January 1759. Messier actually did recover Halley's Comet. Unfortunately, this German chap, Pallich, had got there first. Christmas Day evening, 1758. That's a picture of Pallich. I don't know whether it was listed in the source I consulted that this picture was contemporary. But that looks awfully like 19th century printing to me. There's a photographic quality about it, which you don't normally see in 18th century pictures, certainly not ones that have been printed. Anyway, whatever, that's what he's supposed to look like. Now, Delisle, perhaps because Pallich was German and Delisle was not, didn't accept this finding. It would also have meant him accepting that he calculated the path of Halley's Comet wrongly, which he probably didn't wish to do. But anyway, so Delisle kept Messier looking for the comet and at the comet until the 1st of April 1759. I don't know if the French have an April Fool's Day, but it does seem a strange day, if they do, to announce the confirmation of Halley's Comet. That is supposed to be a contemporary illustration of what Halley's Comet looked like in 1759. It's got no attribution, we don't know who drew it, don't even really know where it comes from. You can see it's got a lot of the right things. I mean, it's got a sort of coma, it's got a fairly clear nucleus, it's got a tail, the tail spreads out, so it looks all right. I have to say, I'm quite suspicious. I really wonder if this is genuinely from the time or not, but let's say it is. And this is one of my favourite images. This is from the Giotto mission to Halley's Comet, 1986. My father was one of the few people who saw Halley's Comet twice. He saw Halley's Comet in 1910 when he was 6. His father took him up to, I think, Parliament Hill Fields to see it. And in 1986, I took him up to Alexandra Palace, where a gang of us from the Astronomical Society of Haringey were having a look at Halley's Comet and letting members of the public, including my dad, have a look at Halley's Comet. My father was one of those people who has a very firm grasp on reality. I let him have a look through the telescope at Halley's Comet. He said, yes, Roger, very nice. Didn't you say something about buying me a drink? Man who's got his ideas sorted out properly. Lot of respect for my father. There is the famous Halley's Comet picture. This is one of quite a few, and the immediate problem is obvious. The camera was working automatically. Remember, it's quite a long way from the Earth. There was no way somebody could operate the camera with a joystick or something like that. The time lag was too much. So the camera was aiming at the brightest part of the image. Unfortunately, that jet is the brightest part of the image. So it's the jet which is smack in the middle, not the nucleus which they wanted to look at. Notice the nucleus is irregular in shape. generally. It's a sort of potato shape, and it's full of holes and sticking up bits and so on. Each of these jets will have a depression underneath it because the material which is squirting out, which is mostly water ice, it has to come from the comet. And the water squirts out because the comet gets heated up. The arrangement is quite sensible. You have a dark surface which absorbs the heat very readily, and that, of course, evaporates the ice underneath it, which blows away a bit of the surface. This new comet, by the way, somebody's already mentioned, I think it was John, wasn't it? Has already mentioned that this new comet is chucking out a lot of CO2, which is somewhat unexpected. I agree that's somewhat unexpected. I have to say I'm not terribly impressed by arguments that this thing is a spaceship. I wish it were. I don't think it is. This is probably the only, certainly the only contemporary picture of the recovery of Halley's Comet that Wikipedia could find. I did look for a few other sources, but I couldn't find one. Wikipedia also has the advantage they do have pictures. There's one source about Messier, for instance, which got pages of notes, not a single picture. Anyway, apparently this guy, William Williams, in about 1760, painted this picture of his, I don't think he was his brother, but Francis Williams, who was a polymath living in Jamaica. Most unusually, he appears to have been educated and black. The authorities in Jamaica were not known for educating anyone who wasn't white. So he must have managed to say the right things to the right people. But anyway, apparently he observed the comet, and this picture shows him looking at some impressive book. He's got all sorts of, that looks like a lunar globe there, I think that's a terrestrial one. And that smudge in the sky is supposed to be Halley's Comet. It might even be Halley's Comet. Because it wasn't universally called Halley's at this point. There was several years before people, generally speaking, began to recall it as Halley's Comet. Some years later, Messier published a pamphlet in his own name. This is the pamphlet. 1808, this was. This was the year that Napoleon invaded Spain. And he put his brother, Joseph, on the throne of Spain. If you think that's a somewhat arbitrary process, Napoleon was like that. It's the year following the victory of Friedland, which was over the Russians, and the year before the victory of Wagram, which was over the Austrians. Generally speaking, throughout the Napoleonic Wars, you can generally reckon on at least one big battle per year. I think the only year that they missed was 1811. Now, Messier wanted this pamphlet published officially, but Delambre, who was the controller of the official publications, wouldn't have it. I'm on Delambre's side in this particular incident. The title page tells us that Messier had discovered 20 comets. Notice that's more than I said at the beginning. And that he'd observed 45. Also that he'd paid the rent of the Marine Observatory at the Hotel de Cluny from 1789, when funding by the Navy ceased. The revolutionary government was perfectly happy to pay for a navy, but they weren't happy to pay for the Naval Observatory. Because Messier actually claimed that he had discovered more comets than all the previous comet hunters put together. Whether that was true or not, I don't know. I don't think it actually matters all that much, but there we are. Probably mattered to him. Now, this was a fairly shameless attempt at ingratiation with Napoleon. If you remember, Napoleon was by now Emperor of the French, and his regime went quite a long way to making the Ancien regime look liberal. You had to be a lot more careful what you said under Napoleon than you did under the Bourbons. Napoleon had a much more efficient secret police, largely thanks to a chap called Fouché, who was, how shall I put it, probably one of the most unscrupulous rogues who's ever been in charge of a government department anywhere. Fascinating guy to find out. There are a lot of them. I mean, any government that includes Fouché and Talleyrand. Talleyrand rose under the Bourbons, prospered in the Revolution, despite the fact that he was a Comte de Talleyrand. He did very well with Napoleon, and he represented France at the Congress of Vienna after the end of the Napoleonic Wars. Kind of chap who always lands on his feet. Fascinating guy to know about. Anyway, Messier was after money, position, influence, all that kind of thing. So he calls Napoleon the Great, see Napoleon le Grand on the title page. He cites the discovery of a grand comet, a big comet, on the 8th of August 1769, which presages the birth of Napoleon on the 15th of August 1769. This isn't really astronomy, is it? This is astrology. So Messier goes to town explaining how magnificent this comet is. He mentions that the tail length was 97 degrees. That was the maximum. There's that chap de la Nux again at the Ile Bourbon. I think that's in the West Indies, but I forgot to look it up. If anyone knows better, say so. And obviously such a magnificent comet is exactly the right sort of comet to herald the era of Napoleon the Great. This is a quite inspired piece of grovelling, isn't it? Napoleon doesn't seem to have been interested. Napoleon was so used to this sort of stuff. And no funds were allocated to the observatory, which continued to decline. They weren't even able to do maintenance, or not very much. In the pamphlet, Messier reproduced a star chart which he produced at the time of observing the comet. And you can see as the comet's going along, the tail is getting longer and longer. Throughout the August of that year, the comet became brighter, the tail got longer. Oh, that's surprising. And, oh God, now we've got an Italian name. Eustachio Zanotti, I presume. He was in Bologna, and Messier, who would have been in Paris, observed the tail length at about 15 degrees. Captain Cook, remember this is 1769, this is the Tahiti expedition. Cook is sent to Tahiti to transport basically some astronomers, Green was one of them, to observe the transit of Venus. The idea was that the transit of Venus would be observed from as many places on the surface of the Earth as possible. And by timing the, I can't think of the right words, but you know, when if that's the sun, when Venus starts to cover the sun and then when it finishes, by timing that at various different observation points, you could, with the appropriate mathematics, work out the astronomical unit in kilometres. In fact, of course, because it was being done, so many of the observation points were under English control, the first measurement would actually be in miles. But Cook did carry that out. Incidentally, you know why they had to send Cook? The Admiralty weren't very keen on sending Cook. You don't send your best navigator out on a possible wild goose chase from which he may never return. But because of the problems of arranging for the various expeditions to be exempted from the current war, this expedition sailed late, and only Cook was a good enough navigator to even find Tahiti in time. Although people have visited Tahiti before, its location was not accurately known. So you needed a very good navigator even to find the place. And he found it first try. He was good. He really was good. Yes, I've said all that. And of course, that the data from all around the world was analysed by Euler, who's Swiss. So we got English and French and German and Danish and American, although they weren't independent yet, observations, and they were analysed by a German-speaking Swiss. So it's quite an international effort. And that measurement of the astronomical unit, the average distance from the Earth to the Sun, was not seriously bettered until something like 1927. So it was a damn good piece of work in the end. There is the Great Comet of 1769 over Amsterdam. Looks pretty wet, doesn't it? Mind you, Amsterdam's a bit like London, you know. You might get these nice hot days, but you also get lots and lots of wet ones. End of August, Maraldi and Cassini measured the tail at 18 degrees. This may have been because the atmospheric conditions in Paris and so on were nowhere near as good as Cook's in the southern Pacific. The tail got longer and longer. Messier measured it at 55 degrees, September. Closest approach to the Earth, the tail had got up to 60 degrees. Again, the length of the tail at this point is changing more because the comet is getting closer to the Earth than because the tail is actually changing in length. So I'm only going to go into anything like detail on one comet, that's this one. And of course, this is the one which gave him the opportunity to suck up to Napoleon. Unfortunately, the pamphlet didn't do him any good. No funds or honours were forthcoming. And fellow astronomers roundly condemned him for his sycophancy and resorting to astrology. That's why I said I'm at least some of the way on the same side as Delambre, who refused to publish this officially. So Messier actually published it at his own expense. Apparently the pamphlet sold quite well. I don't think he lost any money on the actual production of the pamphlet. The observatory, though, deprived of funds, was in decay. Maintenance and so on wasn't being done. So now we ought to have a look at the Messier list. A list of fuzzy blobs. Now, this is a modern analysis of them, so I'll have a look at it. 39 of them are galaxies, 5 are planetary nebulae, 7 are other types of nebulae, 26 are open star clusters, and 29 are globular star clusters. Now, at the time he was doing this, most of those categories would have meant nothing. most of those objects would simply be described as nebulae. The globular star clusters would have looked like fuzzy stars. If you've ever looked at, for instance, M13, which is probably the most famous for this country, with a relatively small telescope, that's what it looks like, isn't it? Fuzzy star. Open star clusters, things like the Pleiades and so on, would look like groups of stars. Planetary nebulae and other nebulae would just look like fuzzy blobs. Galaxies will look like fuzzy blobs, some of them with rather odd shapes. So, while that is correct in modern terms, that isn't how Messier would have counted up the objects in his catalogue. And to be honest, if you're looking at what Messier knew about them, this lot is irrelevant. The term galaxy, of course, is a 20th century invention. It comes from Via Galactica, the Milky Way, literal translation. And the Milky Way became the sort of name for any object that looked like a nebula but was made of stars. I think the first person to make the real distinction between gaseous nebulae and stellar nebulae was Herschel. He looked at a number of the nebular objects and he said that as far as he was concerned, some of them looked as if they were made up of myriads of tiny stars, and some of them looked as if they were made of gas clouds. Incredibly good observer, Herschel. And of course, one of the great telescope makers. He may also have been responsible for a great piece of music. Haydn's Creation may have been inspired by Haydn's visit to Herschel. Remember, they were both German speakers. Don't know whether it was or not, but might have been. So, some of those objects would have been star clusters, and the rest would simply have been nebulae, fuzzy blobs. Now, Messier's catalogue was a byproduct. I know you all know that, but let's just emphasise it. He was searching for comets. He made a list of objects that could be mistaken for a distant comet, but were permanent objects in the sky. And he made the list so that if he found an object, he could check on his list, and if it was on his list, he could just move on. If it wasn't on his list, he might have to check it more carefully. So most of these had, at least to some extent, been mistaken for comets. In some ways, Messier does seem to have been proud of his list. He certainly went to some trouble to prepare it for publication, which suggests that it was more than simply a dumping ground. And he began to call it a catalogue of nebulae and star clusters, which of course was correct in his terms. Remember, this is late 18th century. So the 1781 edition, which was the last one he had much to do with, listed 103 items. Most of them had, in fact, I think virtually all of them had been observed by Messier or his assistant Mechin with a 100mm refractor. Observed doesn't mean discovered. Some of them were discovered by either one of them. Some of them had already been discovered by other people and they were simply included in the list. The list, obviously, was designed to save comet hunters time. But that's the thing everyone knows about Messier, that he made this list. A 4-inch refractor, that's what he was using. 100mm, 4-inch refractor. That's not very big. Of course, this is one of the reasons why Messier's list is so useful to amateurs today. If Messier could see it, you can see it. I think that's a fair comment, isn't it? Yeah. They're visible. His objects are visible with relatively small equipment. Now, I think this is worth emphasising. This is a very unusual gesture. When you think how many astronomers have hugged their discoveries to them to prevent other people joining in. But Messier not merely made his discovery, he made them public and said, you don't have to look at these aren't comets. That's an all-sky distribution, and you can see there's a huge concentration of them here in what's now known as the bowl of Virgo. Actually, most of it's in Comet, but there we are. There's also a lot round Sagittarius, but they're not so concentrated. Very unspit systematic survey. I also think this is interesting that Cancer, which is a dull little constellation, isn't it? And Cassiopeia, which is dead easy to find, and Orion, which is the brightest constellation in the sky, have all got the same number of Messier objects too. Ursa Major does rather better. It's got as many as those three put together. So there's the bowl of Virgo and there's Sagittarius. That's a famous print of all the Messier objects. They're all obviously modern images thereof. So the very first list was only 14 objects, 17 of which Messier had actually discovered, and they were not numbered at that stage. 1780 he published the list again, but moved the numbers up to 80, and they were numbered. 1781 was the final version, and that was the first one properly published. As I say, he did spend a lot of time preparing it for publication. So it was officially published in the Connaissance des Temps, 103 objects in 1784. And that's the Crab Nebula, which I've already mentioned. That is, of course, an HST picture. And that is a picture which was taken specially for me on the 28th of August 2025 by David Convery, who is a fellow member of the Hampstead Scientific Society, who have a telescope on top of a reservoir on top of a hill in Hampstead. Jerry knows well. M2 is a globular cluster. If you squint at that, you can see why it could be mistaken for a nebula object. You need a much better telescope to see that it's made of stars. We're almost out of time, aren't we, Alan? Yeah. Okay, well, let's move on. Oh, this one is important, M4. Another globular cluster. This was the first one where they used the HST to try and spot little blue dots, which are young white dwarfs in a globular cluster. And if you look, there's roughly the same number of young white dwarfs as there are red giants. And this is evidence, very good evidence, that our theories of stellar development actually work. There's the famous pillars of creation. NASA found if you got the word creation into the title, you could get a newspaper headline. So you get the pillars of creation, the crucible of creation, and so on. Yeah, trifid nebula, not trifid. There's the dumbbell. M31, the Andromeda Nebula. It was called the Andromeda Nebula in my recollection when I had my first astronomy book, which was Patrick Moore's Boy's Book of Astronomy. Now there's a surprise. It was still called the Andromeda Nebula, although it had been called a galaxy professionally for many years by then. That's probably, I think, the most famous object, actually. And of course, it has the great advantage of being the only external galaxy visible to the naked eye. It's not an easy object to see from London, but on a clear, dark night, you can still see it. I've seen it from Hampstead. I've seen it from Tottenham, for God's sake. Not very well, but I've seen it. Where are we? There we are, a more famous picture of Andromeda. Notice that Messier got the general shape really quite well. But what did he think it was? Nobody had any idea about spiral galaxies in those days. And in fact, when the idea was first introduced by people like Ross, it was ridiculed. Why should anything be spiral? You know. I just want to show you one which I rather like. Oh, there's the Orion Nebula. That looks quite like you see it, with the lizard's tongue. Apparently that was the Arab name for that dark bit there. It's a modern picture. Beehive. The one I wanted to show you, well, there's the Pleiades. How the Pleiades could have been mistaken for a comet, I have never been able to work out. I mean, they're a lovely sight, but, you know, got not much to do with it. Messier also helped to chart the French coast from Cherbourg right round, well, not just the French coast, but right round the Dutch coast and into the Zuider Zee. There's Lord Rosse's sketch of M51, a spiral nebula. That's what they called it then. Oops, go there. And that's a modern picture. And you can see that Rosse's sketch was pretty well spot on, wasn't it? I think I better stop there, hadn't I, Alan? So if anyone's got any questions.
I was just quite interested in what you were saying about the Sumerian texts, the cuneiform, and how that translated. So I was just interested how that was relevant and where we can find more information about that.
The Sumerians were famous for their astronomical observations. Their records, which were very precise, carried through until the fall of Babylon to Alexander the Great's forces, which was in whatever BC. And after that, essentially, Babylonian astronomy came to a halt. I mean, it took a few years, but essentially, once it had stopped being the secret knowledge of the priests lost interest in it. And so that failed. But they kept records, detailed records, over literally thousands of years. So, for instance, they could determine the length of the Saros, which is the period of time over which the 2 lunar months, the synodic month and the sidereal month, they start together and then they get out of step and then eventually they come back together again. I forget how many years it is, but it's a lot of years. But you can find that out quite easily if you've got centuries of data. They'd also, I mean, by the time of the Babylonians, they knew the periods of all the planets. Now, they didn't have the right idea about how the planets moved, but they knew how long it took them to move. They even had enough data, although that really came later, to begin to assess the differences in distances between. Yeah. I mean, these guys were not, you know, we tend to think of them as primitive. They weren't. They knew what they were doing. And the fact that 3,000 years ago, they could write an astronomical report, which if you could read cuneiform, wouldn't in any way sound out of place now. I think that's remarkable.
It is,
Yeah.
I want to look that up.
Yeah. You get all sorts of things like that. I mean, when I was a kid, I used to go and stay down in Gloucestershire, and I couldn't understand what this thing called King Charles's Wain was until I found out there's what I call the plough. If you want another coincidence, the Sumerian and Babylonian name for the plough was the wagon. King Charles's Wain is King Charles's wagon. So the unofficial name had been wagon for 3,000 years. Don't ask me why. I don't even know if the two are similar. Yeah, but things have different names in different cultures. And there can be a very different culture from a farming community up on the Cotswolds than what there is in London. Any more for any more? Stunned into silence, look at that.
How did you get connected with, I wouldn't say Roger Moore, but I don't mean Roger Moore, I mean Patrick Moore.
Patrick Moore, well, obviously I was the right age. I mean, I was 10 when they launched the first Sputnik. 10 when they launched the first Sputnik. I mean, as far as I was concerned, the entire space race was run for my benefit. I did actually work with Patrick Moore about 4 or 5 times. They used to do these weekend courses, Friday evening round to Sunday evening, at a place whose name I've forgotten. It was out near Thaden Boys in Essex. And I was one of the sort of... There was Patrick, and then there was a couple of professional astronomers, and then there was 2 or 3 sort of to move the chairs around and carry the telescopes out, and I was one of them. And as I say, I debated whether Pluto was or was not a planet with Patrick. I think I got about 3 votes out of 70. Go on then. Go on.
So there are a lot of Messier objects in Sagittarius, which is very low on the horizon. I would have thought it would be quite difficult for him to actually see.
They probably were, but don't forget Paris is quite a long way south of London, so they would be better seen from Paris. And skies were darker then.
Yeah. Are there any Messier objects in the southern hemisphere?
They're in the southern half of the sky, but not so many. I mean, the vast majority are in the northern half. I was trying to think of an example. Well, Sagittarius is essentially in the south. Don't forget, of course, that you can observe constellations like Sagittarius much better in a winter morning than you can in a summer evening. I'm sure you've done that.
Thank you, very interesting. You mentioned that Messier used a 100mm refractor to do some of his best work. What diameter of reflector would be equivalent to that, roughly?
In those days, it would be at least an 8-inch, probably a bit more. Remember that mirrors in those days were mostly, in fact, I think they all were at that stage, were polished metal. So their reflectivity was not all that high. The great advantage of the mirror, of course, is you only have to polish one surface and you can support it all the way across. So you can make a much bigger mirror. With a lens, you've got to only support it round the rim. And I don't know if you've ever read this, but you know the Yerkes telescope in America, which is the largest functional 40-inch. Thank you. I'd forgotten. I was carefully not saying how big. But they have a schedule. You have to put the telescope at certain angles when you shut it down. You have to put it at a certain angle. They have a schedule so that the sagging cancels out. Because it's just a lens and it's supported around the edge. With a mirror you can support flat. But yeah, one of the big problems was that they were mainly metal mirrors, which of course made them very stiff, very structurally sound, but their reflectivity was not all that good. And, if you imagine using a mirror that was essentially made of gunmetal, bronze, I forget, there's more tin and some other compound than you would use in gunmetal, but yeah, still the same basic thing.
Okay. Well, firstly, thank you very much, Roger. I learned a heck of a lot this evening. I'm very pleased.
I'm surprised to hear that.
No, seriously. I mean, the depth that you went into, that's quite something, and I'm sure that everybody here found it not interesting, fascinating, and entertaining
Thank
as
you.
well. So would you please like to show your appreciation?